Good day, guys. Once again, we're doing chemistry today. Last class, we were able to finish the series that we're having. So I'm going to have a different topic today, totally. And we're going to be looking at what I call the rate of chemical reaction. Rate of chemical reaction. The rate of chemical reaction. Rate of chemical reaction. Now, chemical reaction on its own is something that everybody must know about. Fine, we know that chemical reaction occurs between a reactant. This is consider reaction A plus B giving you C. It occurs between a reactant and a product. A reactant and a product. Fine, this is what we all know. That when we have a reaction between a reactant and product, that will give us what they call a chemical reaction. Now, what does the rate of a chemical reaction mean? Guys, you need to understand one thing, that because you see that a chemical reaction is between a reactant and a product, does not mean that the reaction will be fast. It means that in a rate of it means that in a chemical equation, in a chemical reaction rather, a reaction can be slow, it can be fast. That's what you mean by the rate of chemical reaction. The rate of chemical reaction tells us the amount or tells us the rate at which the reactant gets converted to product, or at the rate at which the reactant is used up or consumed in the it can be explained in various ways. We look at the reactant, we look at the product. So we can now conclude that the rate of a chemical reaction can be defined as the rate at which the amount of the reactant gets consumed or the product gets formed. Because we believe that in a reaction, the reactant gets consumed with time and products get formed with time. So the depletion of the reactant or formation of this product at a particular time is what is known as the rate of chemical reaction. Now, guys, so we can conclude that the rate of reaction will be equal to change in concentration of reactant. I cannot say change in C over change in time. So change in concentration of the reactant or product with the change in time. That is what rate of the reaction means. Now, it can be expressed. You recall that concentration is measured in moles per dm cube. Why time is what? Second. So the unit can be mole per dm cube per second. Per second. This is the unit. Sometimes you can be asked the unit in an exam. So you need to know the unit of the rate of a reaction. Now, because that a question there, they said when 3 grams of calcium carbonate was added to excess dilute hydrochloric acid, carbon dioxide was formed. The entire reaction took 5 minutes. What is the rate of the reaction? Now, from that question there, we know for certain that rate of reaction is equals to, we are given the mass of the calcium carbonate that got depleted this time. And the mass given to us is 5 grams. 5 grams divided by, and we are given time. The time given to us is in 5 minutes. So since the time is in 5 minutes, since the time is in 5 minutes, we can now conclude from the question that we have 3 grams of calcium carbonate, 5 minutes in the time. So if I use my calculator, I can get that 3 over 5 is 0.6. 0.6 gram per minute. So you can see here, the change in the mass over the change in the time is expressed here too. So you can express it in various ways. The rate of reaction can be expressed in various ways. And that's why you need to understand the meaning of the rate of reaction. The next thing to consider is that how do we measure the rate of reaction? We said it earlier on today, a reactant and product. We believe that the reactant decreases with time and the product gets what? And the product increases with time. How can we now measure it? One way of measuring this is by noting the fact that we vary the mass or concentration of the reactant, which is decreasing, and the product which is forming. Doing that with respect to time can help us determine the rate of reaction. That is one common way that is mostly done in the lab. Another way that can be done is by you measuring the property of that system. You can measure the property with respect to time. The example of that is what? When you have a change in pressure with respect to time. Change in pressure with respect to time. And that one again is what? Change in pH. Change in pH with respect to time. And that one again is that the mass of precipitate formed with respect to time. So there are a lot of them. There are a lot of them. And all these things are ways of also measuring the rate of reaction too. So we cannot vary that amount of substance there with respect to time. Rate curve. Now, what is the rate curve? This is one thing that many people don't understand. Sometimes in the exam, you see a curve, you don't know how to interpret a curve. Why? Because you don't understand the basis of a rate curve. Let's look at something. I will write this A plus B in a different way. Now, let's consider the reaction again. A plus B giving me C. If I have the graph of concentration with against time, this is what is called as the rate curve. We believe something, guys, that the reactant A and B, they get used up in the reaction. Now, one thing we need to also understand in this course, in this subject, is that we need to understand our basics chemistry and our basic math. Fine. We know that from chemistry that the reactant gets used up in the reaction. It gets used up in the reaction. And the product gets formed in the reaction. But mathematically, we believe that the amount of reactant, we have an amount of reactant at maybe 100 grams, but with the rest of the time, it's what? It decreases. And what happens here is that if I have a mass here, or concentration here of A or B, you observe that it what? It decreases with time. It decreases with time. It decreases with time. So this is the curve that belongs to A, B. So why is this? And why we have it is because we observe that the reactant gets used up. The reactant gets consumed. The reactant gets depleted in the course of the chemical reaction. And noting that, you observe that the concentration will change with respect to time. And knowing that if the reactant decreases with time, what will happen to the product? We observe that the product will increase from 0, and that is called what? C. So this is more of like the peak of the reaction. You will get the reason why when we are talking about in this subject today, we will explain something. The reason why we have something like that, we'll explain it further. Now, from this curve here, we can derive a lot of things. And one of it is the average rate of reaction. Average rate of reaction. What do you mean of the average rate of reaction? Average rate of reaction is the change in concentration over change in time. Now, we need to understand something, that in average rate, it is an absolute value in the sense that we don't accept negative values. We only accept positive values. So we can determine the average rate from the curve. So we don't pick the respective curves at different time intervals, and we can determine that. And that one again is what I call instantaneous rate of reaction. Instantaneous rate of reaction. Instantaneous rate of reaction. It is the rate of reaction at any given instance of time. I did that again. That instantaneous rate of reaction is the rate of reaction at any given instance of time. Any time. Once the rate at that time is called the instantaneous rate. For example, now, if the rate at 5 seconds is 0.5 mole per 0.5 mole per second, is molar per second, is known as instantaneous rate. So any time in the curve, so you cannot pick any time in the curve. Trace it, maybe it is under trace it towards the time. You can determine the what instantaneous rate. Fine, you determine such by using a tangential method. But it does not rule out the fact that we can determine average rate, instantaneous rate from this same rate curve. And why the rate curve is very, very important for every student to understand and to also know. Why? Because we can use this to determine the average rate and instantaneous rate of the reaction. Now, knowing that we have what they call collision theory. Collision theory. What is collision theory? My people, collision theory is something that we must all understand. We assume reactants, we assume products, we assume molecules of substances, and we believe that when molecules of substances collide together, they observe that a chemical reaction will occur. That means if there is no collision between particles, there will not be a chemical reaction. I'll take that again. That for a chemical reaction to occur or to take place, there must be what? There must be a collision between reactant particles. Now, we believe in one thing, that although there are many reactant particles that collide with one another, it's not all collision that will go ahead to form a chemical reaction. It is not all. We observe that in the course of a chemical reaction, only few of the molecules will collide together, have enough energy, and make a reaction to take place. Such collision is what is known as what they call effective collision. Effective collision. So we call that collision an effective collision. Effective one. Effective. So when we have, let's say for example, if we have like about 2,000 molecules, maybe like about, let's say like 500 molecules were able to proceed to form chemical reaction. That collision between 500 molecules is what is called what? An effective collision. Now, when I was saying that about collision theory, I made mention of what? Of energy. Now we believe that all these molecules that collide with one another, they have to have what they call, they need to sum up to have what they call an energy. An energy. And fine, we want this reaction to take place. But we need to know that these particles must possess what they call sufficient amount of energy to pass the energy barrier. So you observe that there's always an energy barrier in a chemical reaction. There's always what? An energy barrier in a chemical reaction. Energy barrier in a chemical reaction. So when these particles gain enough energy to pass this energy barrier, reaction will take place. Reaction will take place. Reaction will take place. Why? Because the particles have some high amount of energy to what? To make the reaction to take place. And it has what? More importantly, it has passed the energy barrier. It has passed the energy barrier. Now, for this to happen, we believe that these particles must have what they call minimum amount of energy that will be required to pass this energy barrier. Such energy is what is called activation energy. It's called activation energy. So activation energy is the minimum amount of energy required for a chemical reaction to take place. So when that happens, we say that the reaction has taken place. Why? Because the particles have the minimum amount of energy. The minimum amount of energy. Now, knowing that, one of the assignments I'm giving there in the next slide is, let's consider this in terms of all this energy. Let's consider an exothermic and endothermic reaction. I want us to go and research on it, and let's see what we can gather from such from both reactions. The next thing to consider here is that, fine, these particles collide with one another, but we need to note, how does this reaction take place? We need to note, why will this reaction take place? We need to also note the fact that in this reaction, what is going on? And what is going on is the fact that bonds break and bonds form. When that happens, we see that the reaction will take place. So when bond is broken, bonds are formed simultaneously in a reaction. And when that happens, you say that, my product has been formed. My product has been formed. So, and we need to note that if the energy of these colliding particles is less than the activation energy, the reaction will not take place. It will just simply rebound, just bounce back. Why? Because that energy is not passing that energy barrier. It's not passing it. So it will rebound back, or the reaction will not take place. The reaction will not take place. The next thing we need to consider here is the factors that affect the rate of the chemical reaction. Every student must understand this. And the first one is the nature of reaction. The nature of the reaction. We need to note that the nature of reactant or reaction influences the rate of reaction, influences it. Now, what do I mean by that? Let's consider two reaction medium. Guys, let's consider two reaction medium. This is reaction A, reaction B. Let's assume that there is presence of what I call HCl. The presence of what I call HCl. And this HCl, let's just show it. HCl is present. Now, in this HCl, we are going to the red marker there, telling us that it's HCl. So let me just indicate it so you can get that gist. HCl, dilute one. Let's consider the lumps. Let's consider the lumps of calcium carbonate. Lumps. This is lumps. This is lumps of calcium carbonate. And let's now consider powder. Powder. Now, what happens here, guys, is that we have lumps, we have powder. What happens in this chemical reaction? Now, if this reaction to proceed, we observe that reaction B will occur faster than reaction A because of the nature of the reactant. In the reaction B, we are working with powdered calcium carbonate. In reaction A, we are working with lumps of calcium carbonate. Therefore, we can, in what way will this influence the rate of reaction? Reaction B, because we are using powder, we observe that there's what they call an increase in the surface area of the reactant. Due to an increase in the surface area of the reactant, we observe that this reaction will take place faster than reaction A. It will take place faster than reaction A. Why? Because of the fact that there's an increase in the surface area because of the product form. So increase in surface area. Why here? You don't even have an increase in surface area here. You observe that you have lumps. Before the lumps start reacting, it will take time because of the lumps. But powder, it reacts faster. There's an increase in the surface area of that of the powder form. The next one, we need to also consider the fact that in these solid big lumps, they are not free to move. Look at this powder form. They are free to move in the reaction. They are free to move freely in the reaction. So they have what they call greater tendency to come together and react better because of the fact that reaction B is what? Reaction B molecules or particles there, they move freely. Reaction A are even move freely. Lumps move. So we can conclude that an increase in surface area it can also influence the factor, the rate of reaction. Number two, there's temperature. Now, what happens in temperature? We consider a reaction medium. we observe that when we increase the temperature of a reaction medium, we observe that there's what they call an increase in the collision of particles. An increase in the collision of particles. And when that happens, we observe that that will increase the what? The rate of reaction. It will increase the rate of reaction. That's why you observe. Sometimes some things you even do at home, some basic things you do at home. You see sometimes when you're at home, they'll tell you to what you want to prepare custard or you want to prepare custard. You see that most of the time you don't use cold water, you use hot water. Why? Because of the fact that in that reaction, it's only hot water that it can work with. So there's some lot of reaction that works better with hot water. For example, that is what? The standardization of organic acid solution using potassium permanganate solution. So how does it work? It can only work when oxalic acid gets heated. When oxalic acid gets heated in the reaction, we observe that the products, the molecules of that substances, they get what? Energetic. They are what? They become what? Energetic. Why they become energetic? Because of there's an increase in the kinetic energy of the particle. Yes, many people don't know about that. We observe that what we learned in basic chemistry or basic science is the fact that molecules at rest is called what? Motion at rest, rather. Molecules at rest is called what? Potential energy. While molecules in motion is called what? Kinetic energy. At first, there is no motion. But when you have increased the temperature, you have increased the energy of these molecules. And there's going to be an increase in what? In the kinetic energy. And that will propel the reaction to what? To take place. The third one is concentration. Now, concentration influences the rate of the reaction. We observe that when you put a reactant, it continuously gets consumed with time. After there's reactant there, it gets consumed with time, get consumed with time. But we observe that the reaction normally is always highest at what? At the beginning of the reaction. It is always highest. And gradually what? Decreases. So the rate of reaction is always highest at the concentration when the concentration is high. So it's always highest at that point. But the rate of reaction decreases or becomes slower. Why? Because the reactant is consumed. And when that happens, we observe that we can easily say that concentration influences the rate of the reaction. So that is what happens. So when you are putting more reactant, you are what? You are forming product. Putting more reactant, you are forming product. Why? Because you have increased the concentration of the what? Of the reactant. Next one is what? Is catalyst. What is a catalyst? A catalyst is a substance that alters the rate of a chemical reaction. So a catalyst alters the rate of chemical reaction. One thing many people don't know, which are catalyst speed up reaction, you need to understand the basis of this thing. A catalyst alters the rate of a chemical reaction without being used up. Very, very important. You can see there, without being used up. So what happens to a catalyst is that for a catalyst, some reactions cannot occur on their own. Some are slower. So you need a catalyst. So there are different conditions why you put a catalyst there. So the reason I put a catalyst for it is for it to alter the rate of reaction. For example, now, in the reaction of or in the decomposition of hydrogen peroxide, you using manganese 4 oxide, it helps the reaction. Why? Because it speeds up the reaction. It speeds up the reaction. But you observe that it's not all the reactions that can speed up. Some reaction involves catalysts that will slow the reaction. That will slow the reaction or decrease the rate of that reaction. And that is called what? Inhibitors. That is called inhibitors. Now, fun fact about catalyst. A catalyst does not alter the position of equilibrium. Yes, it does not alter the position of equilibrium or increase the yield of the product. Never. No. It only alters the rate of that chemical reaction. So it does not change the equilibrium position. It does not change it. And it does not change the yield of the product. So a catalyst will do one thing for us. What does catalyst do? It will alter the rate of reaction. How does it alter the rate of reaction? By what? By looking for what they call an alternative route. An alternative route through a lower activation energy. That's why you have what they call a catalyzed reaction and an uncatalyzed reaction. So if you have a reaction like this, something like this can be catalyzed. Then you now have something like this, uncatalyzed reaction. Uncatalyzed reaction. So this is that this is the energy barrier. This is the energy barrier. But now what has happened? You have decreased it, CT. And that will involve what? The lower activation energy for this what? Reaction. So catalysts affect the rate of reaction. And lastly, light. Some reactions are affected by light. A lot of people don't know. That's why some things you see around you, they are due to what? The effect of light. For example, now, if you look at your medicine bottles, many of your medicine bottles are coated with amber colors. Your reagent bottles are coated with amber colors. Why? Because you believe that the light affects the rate of a what? Of the reaction. Rate of the reaction. So example of that is the reaction of halogens with methane. Initially, the first reaction there is what? Is an initiator reaction. We have Cl2 in the presence of what? Ultraviolet light. And what happens? We have what they call the formation of radicals. Radicals. The formation of radicals occurs when what? Chlorine gas reacts in the presence of what? UV light. And that can go ahead to react with what? The methane. To give us HCl plus CH3 dot. And CH3 dot plus Cl free radical will give us CH3Cl. So we have formed a product here through a UV reaction. And this type of reaction is very, very popular. Reactions that involve using UV light, and most of the times are called photochemical reactions. Photochemical reactions. Photochemical reactions. Photochemical reactions. And with that, we've been able to what? Understand the concept of the rate of chemical reaction. The rate of chemical reaction. So with that, I believe that should be all for the rate of reactions. And that is why we need to understand something. We need to understand the fact that certain factors that affect the rate of reaction. So we need to understand that very well. So the light, catalyst, concentration, temperature. Concentration can also be in terms of pressure too. I said that earlier on too. Concentration can be in terms of pressure. So some people will say nature of reactant is different from surface area. Yes, that is true. We can also put nature of reactant as part of it and surface area too. I put nature of reactant and explain it together with surface area. Surface area too is a factor too, but nature of reactant is also a factor. So why? Because nature of reactant, we are looking at the lumps and the powder. But surface area, looking at the fact that the powder from earth can increase in the surface area. And with that, we've been able to understand the basics of what? Of the rate of chemical reaction. So by now, you're able to identify why a reaction will take place slow or what? Faster. So these are the reasons why, because of the rate of chemical reactions. And with that today, guys, we'll end the class here. So I'm going to be starting a new series next class. So please, let's try to be around and let's try to, my assignments, I'll treat that before I leave. So guys, so please note the assignment and also treat the assignment, please try the assignment. So I'll take that in the first class, firstly, before I start the new series. Thanks for your time, guys. I really appreciate it. We'll see you in the next class.